Study with the Pala Engineering and Journal Geology, Parvin Singh book. So, chapter info geological work of waters, work of groundwater. Groundwater, all that water which occurs below the surface of the earth in one form or another. That is as water moving down to greater depth under the influence of gravity or moving in columns and thickness of structured rocks. The aquifers under definite hydrostatic pressures and flowing as underground streams. It's is broadly grouped as subsurface water. The water occurring in definite rock bodies and fully saturating them below levels is further distinguished as a groundwater. Groundwater, like a surface water, is also a very powerful natural agent responsible not only for modifying the existing features but also for creating many other geological features on and below the surface of the earth. Geological work of groundwater may be conveniently studied under two headings, namely chemical work, which is more important, and the mechanical work. So, chemical work of groundwater, the karst topography. Water is a great solvent. Groundwater become an active agent of dissolutions of many rocks like limestones, dolomites, gypsums, rock salt, and the like with which it come into contact during its downwards journey. Below the surface, it has been observed that water dissolves limestone at variable rate that depends upon its temperature, composition, and above all its carbon dioxide content. Carbonated water may dissolve at surface pressure at up to 150 milligram per liter or more of limestone. Similarly, for gypsum, CaSO4 2H2O water molecule, the dissolving capacity of water, especially saline water, is still higher, 2 to 3 gram per liters of water. These examples are enough to illustrate that if given sufficient time, the dissolutions of soluble rocks by groundwater is controlled by a number of factors such as climate, geological structure, topography, porosity, and permeability of the rocks. Compositions of rock, composition of groundwater, especially its salt and gaseous content, flow velocity, temperature, pressures, and depth at which the water comes in touch with the rocks. Obviously, with such a long list of variables, the features resulting from these types of actions of groundwater are complex and variables in nature. Only a very broad generalizations is possible. These collective effort were best studied first in the cast region of Yugoslavia, where a typical landscape has evolved as a sum totals, which was named as karst topography. The terms has now a universal acceptance for a typical terrain, in which the surface and subsurface features in general and relief and drainage in particular are related directly to the solvent action of subsurface water. The most typical features of karst topography are disorderly distribution of landforms, highly irregular and intermittent streams flow, frequently disappearing and often repairing at a different distance and places, abundance of dry valleys as well as marshy and swampy lowland, numerous depressions, hollows, openings, cave, natural tunnels and basins, some of which may be containing water, a centripetal drainage in which streams from different directions flow towards a common certain basin. In every karst regions, all of these features may not be necessarily present. Their development, as said earlier, it controls by mix of the factors operating in a particular reasons. Some of these features may be visible or exposed on the surface, example irregular depressions, and others may be buried, example caves under varying thickness of evolved rocks. According the cast is sometimes distinguished as a bare cast, where the solutions forms are exposed on the surface. Covered cast, where the rock's bearings features of solvent actions are present under a thin cover of insoluble rock. And subjacent rock cast, where the cover over the affected rock is quite thick. Quite a number of forms are developed due to solvent action of water cast in cast erosions. Of these, only a few are mentioned below in outlines: dolines, cave, and blind valley. Thank you.